present our STEM project that its name is Impacto Impulso. My name is Carlos, and my partners are and we're going to start.
Está prendiendo el control.
Se le está apagando la pila, se está apagando.
Ponerle manual.
Pícale allá.
No, o sea,
¿Me pongo allá mismo?
Okay, so our objective is to show people that the force acting on an elastic collision is the same as the kinetic energy that is on the object that it's colliding. Okay.
This is the theoretical framework, and kinetic energy is the energy of motion, and any object that has motion has kinetic energy. The amount of kinetic energy depends on two variables, the speed and the mass. An elastic collision is a collision in which there is no change in the kinetic energy and in the system. As a result of the collision, both momentum and kinetic energy are conserved quantities in elastic collision.
well, as we use a spring, we'll have to know first what is a spring. A spring is an object that can be deformed by a force acting on it, and an elastic object, when a force is acting on it, can be either compressed or stretched. This is a reaction that has a spring on the force. There's a law that is called the Hooke's law that we can ascertain limit. It states that the force required to stretch an object is directly proportional to the amount of length that the extension of the spring has. And this is a formula that which F represents the force, K is the constant of elasticity of the spring, and X is the distance that the object has. As you can see here, this is the X. This is spring at normal state. When you stretch it with a certain mass, it come a different distance. That is the one that is going to be applied to the formula.
So the description of the model, the materials needed were 2 wooden tracks, a spray paint, screws, nails, hinges, a screwdriver, drill, spring, saw, plate, track, and ball, and also ink. So what we did is we needed 2 wooden tracks, one for base and one for use it as an indicator of the angles, as you can see here. And then place the track with the hinges. Here are the hinges, as you can see. So we support it with a tiny piece of wood, that is this one, that we could replace it in the angles. So then place the ball in the top. So place the ball in the top of the track, then let it go to hit the clay. This is the clay to cushion, and the ball will hit the spring.
The mode of operation of formula. First, a team member have to put some ink on this little paper that is above the spring. This paper is going to measure how much does the spring compress. Then you have to form this edge of the ramp, because as the ramp changes its angle, it has to have just a little inclination in order to hit the spring in a correct way. Then the student will put the ramp in the angle that he prefers. We have too many options here. For example, if you want to put it here or down here. Then you have to take the ball and just let it go from the top of the ramp, and it will hit the spring. And as it has some ink down here, going to measure how much does the spring compress. Then you have to do it several times with different angles, and you have to compare the marks on the paper, and you will see that there is a difference between the angles and how many force does it apply on the paper.
Are you gonna do it?
Yeah. Here you can see that the mark is just about a centimeter until here, and then I will apply another angle. And then the mark is just about here. It is like 6 or 7 centimeters. So you can see that there is a difference between throwing the ball from here and from here.
Do you have calculations?
Yes, we're placing the formulas that what we started before. If you want it, we can do it right now.
Are you going to present them? Do you plan to present them or not?
The calculations, they're not actually, the student must do it for practicing the knowledge that it's supposed to acquire before using the model.
Okay, it's not part of the presentation.
No.
Okay.
Okay, so here are the benefits of the device. And when we were making our model, we were thinking also about the benefits. That is an important part. And we wanted to have benefits for every kind of people, not only for ages. I'm talking about for every kind of intelligence. We have like the visuals. You can see the model. You can interact for the like the kinetic intelligences, kinesthetic intelligences. We also have the theory, and that's like our benefit. One of our benefits, because it's in order to make for every kind of person. So you can be like more interested in physics and math topics, and it can be easier. So basically, those are our benefits.
Well, as a conclusion, the force acting on the lasting collision is equal to the kinetic energy of the object, but it changes depending on the height of and the angle of the ramp, as we could see in the demonstration.
These were our references.
Something else?
That's it. Thank you.
Thank you.